Ladies and gentlemen, thank you for your patience and welcome to today's Rocket Lab third quarter 2022 financial results conference call. My name is Amber and I will be your moderator for today's call. All lines will be muted during the presentation portion of the call with an opportunity for questions and answers at the end. If you would like to ask a question, please press star one on your telephone keypad. I would now like to pass the conference over to our host, Mariel Baker, Communications Manager with Rocket Lab. Mariel, please proceed.
Thank you. Hello, everyone. We're glad to have you join us for today's conference call to discuss Rocket Lab's third quarter 2022 financial results. Our presenters are Rocket Lab founder and CEO, Peter Beck, and Chief Financial Officer, Adam Spice. After our prepared comments, we will take questions. Before we begin the call, I'd like to remind you that our remarks may contain forward-looking statements that relate to the future performance of the company, and these statements are intended to qualify for the safe harbor protection from liability established by the Private Securities Litigation Reform Act. Any such statements are not guarantees of future performance, and factors that could influence our results are highlighted in today's press release, and others are contained in our filings with the Securities and Exchange Commission. Such statements are based upon information available to the company as of the date hereof and are subject to change for future development. Except as required by law, the company does not undertake any obligation to update these statements. Our remarks and press release today also contain non-GAAP financial measures within the meaning of Regulation G enacted by the SEC. Included in such release is a reconciliation of these non-GAAP financial measures to the comparable financial measures calculated in accordance with GAAP. Lastly, this call is also being webcast with a supporting presentation, and a replay and copy of the presentation will be available on our website. Now let me turn the call over to Peter Beck, founder and CEO.
Thanks, Mariel, and welcome everybody to today's review of Rocket Lab's business highlights and financial results for Q3 2022, presented by myself and our Chief Financial Officer, Adam Spice. Today's presentation, we will go over our business accomplishments for the third quarter and further achievements we've made since the end of the quarter. We'll also include commentary on our market position across launch and space systems and discuss some of the big contracts we have underway. Adam will then talk through our financial results for the third quarter and our financial outlook for Q4. After that, we'll take some questions from those listening and finish off today's call with up-and-coming conferences we'll be attending. All right, on to what the company has achieved this quarter. The quarter ended strongly for Rocket Lab on the launch side of the business as we equaled our record for the number of successful launches to orbit per year, quickly surpassing it within the first few days of the fourth quarter. We completed 2 flawless national security launches, one after the other, for the US government's National Reconnaissance Office. The NRO are a prime customer in the launch business with stringent mission requirements, and so it's both an honour and a show of our strength as a launch leader that they continue to return to us to deliver their national security missions to orbit. Our third mission was the second of a bulk buy of dedicated launches for Japanese constellation builder Synspective. Electron again performed perfectly to deliver Synspective's payload to the exact position required to support their constellation growth. Flying dedicated offers multiple benefits for small satellite constellation operators. These include control over their own launch schedule and ability to reach specific LTANs that aren't achievable if they fly on a rideshare mission. These reasons, along with Electron's reliability, are why customers are coming to us and booking up multiple launches at once. Synspective's bulk buy of launches will continue into 2023, with another launch scheduled for then, along with grouped launches for French constellation operator Kinéis, and another set for US operator Hawkeye 360, expected to launch in the first half of next year. Sticking with Electron, we successfully fired a Rutherford engine that had been returned from the ocean during one of this year's earlier recovery missions. With that is a massive technical achievement on the path to rocket reusability. Electron, Photon and Neutron are in the scope of the US Transcom research contract awarded to Rocket Lab this past quarter to examine their potential use for cargo transport and point-to-point travel. Speaking of Neutron, the program achieved some key wins and engineering milestones this quarter, including the selection of a new site for Rocket Lab to develop Neutron's Archimedes engines and the production of full-scale hardware, including Neutron tank structures and Archimedes engine prototypes. I'll take you through those achievements in more detail later in this presentation. On the space system side, some of our earlier investments to grow the production capability of each of these space systems streams really started paying off. In particular, we announced today that our separation systems division has secured the largest bulk order ever, totaling over $14 million. Those 80-plus separation systems will support the Department of Defense Space Development Agency mission to build a constellation that will serve the future national defense and space architecture. As missions like these continue to come into the fore, our shored up production capacity across vertical space system streams means that we're ready and able to service these types of large contracts now and into the future. Alongside this separation systems win, we also completed the high volume manufacturing line for our satellite reaction wheels that will service an undisclosed mega constellation customer. This production line is capable of manufacturing up to 2,000 units per year and produced its first engineering units this quarter, which keeps us on track to start producing flight-ready wheels early in 2023. Rounding out our Q3 highlights for space systems, we also were awarded a contract to provide solar power technology for 3 Lockheed Martin-built satellites for the US Space Force. Okay, so 3 launches. As I mentioned at the top of this call, we had a strong quarter of launches with 3 successful orbital missions for Electron. 2 of these were for the NRO office, and the third was for a Japanese constellation operators inspector, both repeat customers for dedicated Electron launches. Since April, we've maintained a launch cadence of once a month with 100% mission success, and we're on track to maintain that tempo for the rest of the year, including our first launch from our launch site in Virginia, Wallops Island. With our Synspective mission, we equaled our previous annual record of 7 launches a year, only to beat it in the first week of Q4 with our 8th successful orbital mission, and again with our 9th mission just 5 days ago to deliver a total of 152 satellites to space. Even without these 4-quarter launches, our missions in Q3 cemented our position as the launch provider of choice for small satellite operators and further stretched our lead as the most frequently flown and reliable small launcher. I know I said I would go over a rocket reusability program later in the call, but first I want to point out a key technical milestone we achieved in a third quarter for that program. For the first time, we successfully fired an engine with reused parts from the previous Electron mission that was recovered from the ocean. This particular Rutherford engine was previously successfully launched to space and returned to Earth during our recovery mission there and back again in May. The refurbished Rutherford engine passed all of the same rigorous acceptance tests we put in every flight engine through. It fired for an accumulated 200 seconds, restarted multiple times, produced the same amount of thrust and performance as a newly built engine, so good as new. This is very exciting because the fact that we achieved such a high level of performance from an engine when we dredged it out of the sea makes me excited and optimistic about what we can do with the recovered dry engines, and further validates that we're on exactly the right path for bringing reusability to small launch vehicles. Onto our responsive space program. In Q3, we opened up our responsive space program to on-ramp commercial and government satellite operators to a rapid call-up launch capability and streamlined satellite build and operations options. There's been a lot of talk in the industry and a number of line items and government budgets about responsive space. It's a capability that's been sought for decades and enable satellite operators to rapidly call up a launch service, get it to space in a short time frame. But the reality is, responsive space, at least for us, already exists for small satellites, and that it exists with Electron. There's a lot of talk about it, but we've actually demonstrated it. Our fastest launch turnaround time this year was a sum total of just 15 days, which comes down to the maturity of our rocket, our infrastructure, and our team. We introduced this program to formalize what we already offer to the market, and we're seeing strong interest already from repeat and future customers. Onto Neutron. Excuse me. So as I've described, a good quarter for Electron, but Q3 also saw strong progress for our large rocket, Neutron, and I'll take you through some of those key achievements now. To start with, Neutron has a new home, or at least Archimedes engines do, at NASA's historic Stennis Space Center in Mississippi. In late September, we selected Stennis as the location of the engine test facility for our reusable rocket engine, Archimedes, which will power the Neutron rocket. And just last week, we cut the ribbon on Stennis along with the Mississippi senators and other senior figures in attendance there too to show a strong local and federal support that we have for Neutron. The Archimedes Test Complex will be located within the larger A Test Complex at Stennis Space Center across a 1 million square foot area. The site itself already comes with all manner of critical infrastructure like cryogenic systems, tanks, test systems, instrumentation bays, buildings, and a whole lot of more that we can quickly adapt to support our engine test operations. We can also leverage the wider Stennis Centre's infrastructure for power systems, transportation networks, commodities and supply chains, all the little things that make our test site run and tick quickly. That allows us to get set up quickly and get testing faster than if we had to build engine test site from scratch. The state of Mississippi has really gotten behind us to bring Neutron to the area too, with the state putting forward some significant capital investment for us to develop the facilities for Archimedes and Neutron. Moving into Stennis really fast tracks development for Neutron, and already the team on the ground are getting to work to modify some of the systems and get the site ready for the very first Archimedes engine hot fire. Speaking of Archimedes, this past quarter saw progress on the development of our new reusable rocket engine. We made a change in the cycle of the engine from a gas generator to an oxidizer-rich closed cycle to really optimize the performance of the engine, not to increase the level of ISP or performance as you might think, but to maintain a power balance right in the middle that brings the temperatures and chamber pressures down for a super reliable engine. Because that's what you want in an engine for a reusable rocket, an engine that can be used over and over again, and which has a scope for increased performance if we need to, or throttle up or throttle down for any re-entry and landing at the pads. So with that, all of the major design elements of the engine are complete. This quarter we moved into producing some early prototype parts, 3D printed components including pump parts like oxidizer, volutes and others. With Stennis secured and the engine development ready and accelerating now, we're on the right track with Archimedes and well positioned to maintain our targets to see a hot fire engine soon. Continuing on the Neutron theme, Neutron is a unique rocket not only in its design but in the materials we use to construct it. It's expected to be the world's first carbon composite large launch vehicle made up of new specially formulated carbon composite materials, obviously lightweight and very, very strong. But the new element of being able to withstand the heat and forces of repeated re-entry and launch. Now, we use carbon composites for Electron. In fact, we were the first in the world to build an all-carbon composite orbital rocket. So we understand these materials and these technologies really, really well. Now, with carbon composite, carbon composite rocket, one of the best ways to determine the program's progress is whether structural molds for the rocket are complete or not. Because if molds are built, that means that the rocket's design is mature enough to invest in the capital and the tooling. And that's where we are today with Neutron. In Q3, we completed the molds for its tanks and have started to develop full-scale prototype hardware so parts can be made quickly to speed up Neutron's timeline. This type of advancement in the program might not seem too flashy, but it's highly important for Neutron's early development. We're expecting the first Neutron tank to come to life by the end of the year, this prototype tank. Now, to build Neutron's carbon composite tanks and structures quickly, the best way to do that is by automation. And this is another area this quarter that we've completed early investment into and the tooling and the machinery by using rocket building robots. The process is called automated tape laying. It's quite a mature process where meters of carbon fiber are laid down every minute to build the structural material up for Neutron's structures. It's an advanced composite manufacturing technique that's really optimized for performance, speed, and cost. Carbon composite on a strength to mass ratio is at least 4 times lighter than metallics like steel, meaning that a quarter of the amount of the material actually needs to be used for the same specific strength. And in using our rocket building robots, we can really maintain and minimize labor and still manufacture completed tanks in a very short time frame, in the order of days. Out to the East Coast now to Virginia, and we continue to make really good progress on the Neutron factory there. The 28-acre area was literally a greenfield when we started, and has now been graded concrete poured and the first buildings up within just 7 months from groundbreaking in April this year. We're expecting our first stage 1 neutron tank to complete it on the site 2, which has been kicked off in this current quarter. The site here for our production complex for Neutron that will support its production and assembly and integrated launch. It's where we'll build the rocket, but it's also we will do some of our tests and some of our system infrastructure will be there as well. The thing about the site, site and the advantage we gain from its location is how close it is to the Neutron launch pad. In fact, just 2 miles up the road. This allows us to unlock all of the constraints that a typical rocket program otherwise faces. There's a reason why most modern rockets are about a little bit over 3 meters in diameter, and that's because they have to go through some kind of tunnel or bridge somewhere on the way from their production site to the launch site. That's not going to be the case for Neutron. It's a unique proposition, and that we have with the launch site and pad and production code complex of Neutron's major functions being so closely located. Where we can build the rocket, but also test it in very close succession to really help accelerate Neutron's development timeline. Once Neutron is up and flying too, it will mean slick and streamlined operations in a place where we're not handling the rocket multiple times and transporting it through various parts of the country to get it to the pad. Right, on to Space Systems. So moving into Space Systems now and some of our accomplishments here in the quarter. The ethos of our entire Space Systems line has been to enable easier and faster access to space on proven and affordable hardware that is available at scale. Our satellite separation system by PSC have been a key offering of our vertically integrated Space Systems business, having come to the table with 100% mission success heritage across more than 100 missions launched across most major US and international rockets. Being acquired by Rocket Lab meant PSC could continue their commercial hardware trade, but by tapping into Rocket Lab's resources and manufacturing capability, grow the business. And so it's fantastic to share today that in under a year since the acquisition, we recently brought in our highest value mission for separation systems to date. 2 orders totaling $14 million, and I'll take you through that deal in more detail in the next slide. The $14 million win is made up of 2 contracts to supply more than 80 of our light bands to Lockheed Martin and another undisclosed customer who are both building satellites for what's called Tranche 1 tracking layer, which is being developed by the US Department of Defense Space Development Agency. These 80-plus light bands represent the majority of the separation systems required to deploy the entire Tranche 1 tracking layer constellation, an early warning global system to detect missiles and protect US national security. This is a critical capability that relies on the satellites and the constellation being accurately deployed to their precise location. So the fact that not 1 but 2 organizations have entrusted us to build these devices that place the satellites in orbit tells you just how well regarded our separation systems are in the market. Further to the US government side of the business, in our solar power division, we secured another win with an award to deliver the solar cell assemblies for 3 Lockheed Martin-built satellites for the United States Space Force. These 3 large spacecraft are part of the latest evolution of the USSF's missile warning system and recently passed the critical design review to become certified for space, set to launch in 2025. Our deep expertise in space solar power, reliability of the tech, and our extensive manufacturing capability are some of the reasons behind the latest award, which supports satellites production on a really aggressive schedule. Onto Mandrake. Over in our mission software department, our team and technology have been helping progress a major US government program called Blackjack. This program is being managed by DARPA and the government's Space Development Agency to create a global low-latency, high-volume data communications constellation using optically interconnected satellites. An early test of that network was carried out in June with the success of the Mandrake 2 mission, which successfully demonstrated a functioning optical communications link between 2 satellites. We played a leading role in the success of the Mandrake mission with our software and our mission simulation and testing solutions have been a part of the mission from the very beginning of the program. We also run mission operations for Mandrake, where the team is responsible for daily spacecraft health and status monitoring, payload tasking, and trajectory control between the 2 spacecraft to support the optical cross-link testing. And while we're counting this mission as a win for our space systems business, it's also an example of a vertical integration strategy and space systems paying off across the board. We supplied the star trackers and reaction wheels to the Mandrake spacecraft, which enable it with the high precision control it needs to achieve the optical communications link. And our separation systems were also used to deploy these satellites to space. Another showcase this quarter of the strength of our end-to-end mission solutions was the award of a new research and development agreement with the United States Transportation Command, or US STRATCOM. US STRATCOM are responsible for all global logistics for the US military. It's DoD's future thinkers, and they're looking forward to a rocket cargo transport and point-to-point travel for its operations in the years to come, and see an opportunity across both our space systems and launch offerings. In Photon, our research agreement will explore the use of our spacecraft to establish on-orbit cargo depots and deliver re-entry capabilities, while Neutron and Electron are being examined for their ability to transport cargo point-to-point around the world. And then finally on to our Q3 three highlights. We've completed the construction of a high-volume space systems production line to produce reaction wheels at scale. Our first prototypes for one of our mega constellation customers has rolled off the line and is completing its testing before we begin delivering the final products early next year. This production line is capable of producing up to 2,000 units a year, which is an enormous increase in the availability of these critical products to the market. Where components like reaction wheels have been individually built by specialized engineers, over long wait times. For this production, we've incorporated advanced metal machining centers optimized for unattended operation, automated production tools, and automated environmental testing and workstations. This production line coming online means we're meeting the bottleneck of demand for these products for satellite constellation builders head on, where we see significant growth opportunity in our space systems division. Post-quarter accomplishments. So as you saw there are another really good quarter from those business accomplishments in Q3. Now I'd like to take you through a few more exciting developments for the company since the quarter end. So busiest launch year. So starting with Electron, we've had our busiest launch year. Just a week into the fourth quarter, we successfully launched our 8th mission. 5 days ago, we launched our 9th mission of the year, and surpassing our record for the calendar year. We said we'd open up access to space with Electron with an increased launch cadence, and we have, with a successful orbital mission every month this year since April. In fact, Electron has launched successfully more times this year alone than every other commercial small launch vehicle combined across all of their launches to date, and we're still not finished. So Electron and our team have had a stellar year, picking up the pace while also delivering some of our most demanding missions ever. Arguably, our hardest mission was the Capstone mission, sending a satellite to the moon on Electron and one of our Photon spacecraft. It was the heaviest mission we'd ever lifted, the most technically demanding on the rocket, and then only 15 days later, our team turned around and for a flawless launch of one of our highest level national security customers there is, and that being the National Reconnaissance Office. We've had this success because we've advanced the technology, built the infrastructure up front, set up 3 launch pads and 3 operation centers, developed a world-class team of engineers. Electron has really hit its stride this year and is well set to continue an increase in cadence in 2023. Before that, though, we have another Electron mission to fly, our 10th for 2022, this time flying from Rocket Lab Launch Complex 2 in Wallops Island, Virginia. Launching from this pad is going to open up a new era in launch for small satellite customers. We've been providing reliable and responsive access to space for more than 4.5 years now, and excited to build on that strong heritage by unlocking a new path to orbit from Virginia's eastern shore. Across these 3 pads, both of our launch sites, we can support more than 130 launch opportunities every year to deliver unmatched flexibility in the market for government and commercial satellite operators. On the AFTS front with NASA, we've been encouraged by their recent progress and their expression of confidence that they will be ready to go by December. Electron arrived in Virginia last month and is deep into processing and already on the ground by the team. Launch rehearsals and integration of the Hawkeye 360 payload to the rocket will be taking place in the next few weeks before rollout, to the pad at LC2 for a launch. I'm personally very much looking forward to seeing this Electron fly out of Virginia, as you might imagine. Finally, I'm also excited to announce today that we have our second launch lined up from LC2 for an undisclosed commercial constellation customer on an Electron in January, meaning that we'll have 2 back-to-back missions from Virginia in just a matter of weeks. Even in its early days of flying from LC2, Electron is set to change the game and set the standard for responsive and reliable small launch from US soil, with these 2 missions expected to be the fastest launch turnaround by any operational small launcher. Electron is already the most frequently launched small orbital rocket globally, and with both these complexes combined, the pace is really expected to pick up. This launch in January from LC2 will be Rocket Lab's first Electron launch in 2023 as part of a busy launch manifest. Other launches already announced for 2023 include the first of 5 dedicated missions for Internet of Things connectivity provider Kinéis, the launch of a mission to demonstrate space debris removal technology by Astroscale in Japan, and the continuation of a multi-launch contracts with Hawkeye 360 and Perspective. This is not an exclusive list of all of our manifests for 2023, but it's just some of the customers that we've already announced this year. Moving on to Space Systems now, and our contract to NDA for Globalstar has been expanded to include us developing a new Global Satellite Operations Control Center, what we call the SOC, for the constellation. We'll not be disclosing the terms of this contract, but I can tell you it does represent an extension to the $143 million contract already in place. The foundational mission software for the SOC will be based off our existing MAX system, the same one used to manage the DARPA Blackjack program that I spoke about earlier. The combination of our software and deep expertise in operating demanding and complex missions, alongside our existing partnership, where we're the driving forces behind the NDA, choosing to extend this opportunity to us. By designing and manufacturing Globalstar's spacecraft buses, delivering the flight and ground software solutions, and developing and supporting the spacecraft operation centers, we're once again demonstrating that our strategy of going beyond launch and delivering complete space mission solutions, basically end to end. A big part of our growth and acquisition strategy has been the vertical integration of supply chains to mitigate constraints. The strategically important components needed to build out a functioning satellite as part of the constellation. The companies we've acquired over the years, we believe, are the best in the business in their own right. But more importantly, combining them has provided us with inorganic and organically developed solutions that cover the complete mission end-to-end to deliver an operational platform that's going to be used globally. And this NDA contract is a perfect example of that. We're building all 17 of the constellation's new spacecraft buses. The SOC's Globalstar mission will use our software. The satellites themselves will be powered by our solar panels. They'll communicate using our Frontier C satellite radios. They'll maintain their position in space using our reaction wheels. Each satellite will be operated by our software, and they'll have power distribution systems internally built by Rocket Lab. The customer also has the option within this contract to launch these satellites with us. Additionally, there's an option for us to support the ground operations for Globalstar as well. The strength of our competitive advantage in vertical integration really shines with this contract. It helps to reduce the cost of our own systems, but also allows us to monetize it. And the diversity of the revenue that you're seeing from us is a combination of that. Speaking of revenue generation in Space Systems, early in the fourth quarter, we signed a contract with NASA's Jet Propulsion Laboratory to provide solar panels for shoebox-sized mobile robots as part of the agency's CADRE program. The CADRE acronym stands for Cooperative Autonomous Distributed Robot Explorers, much easier to just say CADRE, which NASA's next generation of planet explorers that will work as a group to collect data from hard-to-reach places on the Moon, Mars, and elsewhere. They're going to be powered by our IMM solar cells, a superior type of space-grade solar cell we provide for the most innovative and far-reaching customers' missions. The latest contract with JPL extends our long history through SLERA of powering NASA's satellites and spacecraft, including NASA's Ingenuity helicopter. We'll be using the same solar cells on CADRE as we did for the Ingenuity helicopter, Mars helicopter, with the higher efficiency and lower mass combination in those cells being deemed a critical factor for enabling the mission's success. So with that, let me turn it over to Adam Spice, our Chief Financial Officer.
Thanks, Pete. I will first review our third quarter 2022 results and then discuss our outlook for the fourth quarter. Third quarter 22 revenue was $63.1 million, exceeding the high end of our guidance range of $60 to $63 million, representing 14% sequential growth over the prior quarter. Our record revenue performance in the quarter was a result of 3 successful launches, as well as outperformance in our Space Systems segment, led by our Separation Systems product line. Launch services contributed $23 million, delivering 20% quarter-on-quarter growth and representing 36% of the total revenue in the quarter. Space Systems contributed $40.1 million, delivering 10% quarter-on-quarter growth and representing 64% of total revenue. Now turn to gross margin. GAAP gross margin for the third quarter was 13%, which was within our guidance range of 12 to 15%. Non-GAAP gross margin for the third quarter was 24%, which was within our guidance range of 22 to 25%. Compared to the second quarter, where GAAP and non-GAAP gross margins were 9 and 22% respectively, both GAAP and non-GAAP margins expanded in the quarter. In the Launch Services segment specifically, GAAP gross margin for the third quarter was -4% versus -12% in the second quarter. This expansion of gross margin was the result of higher average selling price per launch vehicle and lower production-related stock-based compensation expense. In the Space Systems segment, GAAP gross margin for the third quarter was 23% versus 20% in the second quarter. This expansion of gross margin was driven by a greater mix of higher margin satellite component revenue, such as Separation Systems and reaction wheels delivered in the quarter. Total production headcount ended September 30th, 2022 at 797, up 16 heads from June 30th, 2022. In the face of increased production unit volumes, we continue to focus on constraining production headcount and identifying production efficiencies in pursuit of expanding gross margins across the business. Backlog declined $10.8 million during the third quarter to $520.6 million as a recognition of record revenue outpaced new bookings in the quarter. Significant portions of our business involve projects that are many months or years in formation, and as a result, converting opportunities into new bookings is lumpy. Our pipeline of opportunities remains robust, and we are confident in our ability to build our backlog over the coming months and quarters. When we compare the third quarter 2022 revenue on a year-on-year basis, the continued strength, evolution, and diversity of our business is evident. Total revenue was up more than 1,000%, or more than $57 million when compared to the third quarter of 2021. Acquisitions have contributed meaningfully in this year-on-year growth, reinforcing the strategic importance of our early investments into expanding our total addressable market. Specifically, revenue contribution from the acquired ASI, PSC, and Celero businesses added approximately $31 million of revenue in the third quarter of 2022. The remaining Rocket Lab product lines have experienced significant growth as well, having grown more than $27 million over the same time period, representing 514% growth year-on-year and contributed nearly $32 million in the third quarter of 2022. Now turning to gross margin. GAAP gross margin for the third quarter was 13% compared to -230% in the third quarter of 2021. Non-GAAP gross margin for the third quarter was 24% compared to -84% in the third quarter of 2021. I'll be mentioning the impact of lower stock-based compensation on GAAP cost of goods sold and on GAAP operating expenses in the year-on-year compares, which was a function of the timing of our de-SPAC and the related one-time catch-up of recognition of stock-based compensation related to restricted stock unit vesting that had a performance condition related to achieving a liquidity event. The current quarter stock-based comp represents a more normalized run rate-based stock-based comp level. In the Launch Services segment specifically, both GAAP and non-GAAP gross margin for the third quarter 2022 expanded significantly over the third quarter of 2021 as revenue growth led to greater absorption of production overhead as well as lower production-related stock-based compensation. In the Space Systems segment, both GAAP and non-GAAP gross margin for the third quarter of 2022 declined versus third quarter of 2021. The decline was driven by the acquisitions of ASI, PSC, and Celero, which added significant revenue contribution, but at lower gross margin profile versus our much smaller Space Systems business in the third quarter of 2021. Turning to operating expenses. GAAP operating expenses for the third quarter were $40.5 million, which was approximately $500,000 lower than our guidance range of $41 million to $43 million. Non-GAAP operating expenses for the third quarter were $27.4 million, which was within our guidance range of $27 to $29 million. The growth in both GAAP and non-GAAP operating expenses versus the second quarter was primarily driven by an increase in staffing, prototyping related to Neutron vehicle development, the Electron booster recovery initiatives, and Photon development projects, which were partially offset by the change of fair value of contingent consideration related to the PSC acquisition and deal-related amortization of intangibles. In R&D specifically, GAAP expenses decreased by $1.7 million, or 9% in the third quarter, driven by lower stock-based compensation. Non-GAAP expenses were up $1.1 million, or 10% quarter-on-quarter. We anticipate the trend of sequential growth in R&D to continue as we ramp investment in our Neutron launch vehicle and in Photon development in particular. Quarter-ending R&D headcount was 348, representing an increase of 40 heads from June 30th, 2022. In SG&A, GAAP expenses increased quarter-on-quarter $4 million, or 21%, driven primarily by the earlier mentioned change in fair value of contingent consideration related to the PSC acquisition and deal-related amortization of intangibles. Non-GAAP SG&A expenses increased by $1.1 million, or 8% quarter-on-quarter, mostly driven by increased staff costs, as well as higher travel and marketing costs. Quarter-ending SG&A headcount was 196, representing an increase of 14 heads from June 30th, 2022. On a year-on-year perspective, both GAAP and non-GAAP operating expenses increased as the company continues to invest heavily in Neutron development, broadening our Space Systems portfolio of products and services, and Electron recovery initiatives. The company is executing and achieving milestones on numerous ambitious projects, and we look forward to these investments generating shareholder value for years to come. Year-on-year GAAP R&D increased $3.3 million, and non-GAAP R&D increased $4.3 million, driven by increased staffing and prototyping expenses for our Neutron and Photon development projects. Year-on-year, GAAP SG&A was down $2.7 million, driven by a decrease of stock-based compensation, partially offset by an increase in amortization expense related to the ASI, PSC, and SolAero acquisitions. Non-GAAP SG&A was up by $7.8 million, driven by higher public company costs, including audit, legal, and D&O insurance. Cash consumed from operating activities was $23 million in the third quarter, compared to $38.3 million in the second quarter. Sequential decline of $15.3 million was driven primarily by an improvement in working capital, as well as lower net loss in the quarter. Cash consumed from investing activities was $188.7 million in the third quarter, compared to $12.3 million in the second quarter. The sequential increase in cash consumed from investment activities was driven by the purchase of $179.9 million of marketable securities. Cash generated from financing activities was $2.1 million in the third quarter, compared to cash consumption of $15 million in the second quarter. The sequential increase of $17.1 million was driven by lower tax withholdings paid on behalf of employees for the vestings of restricted stock units during the third quarter, as well as a one-time contingent consideration payment in the second quarter related to the ASI acquisition. Overall, cash consumed in the third quarter was $210.3 million, compared to $61.1 million in the second quarter. The ending balance of cash equivalents, restricted cash, and marketable securities was $515.5 million as of the end of the third quarter, representing a decrease of $31.2 million sequentially. And with that, let's turn to guidance for the fourth quarter of 2022. We expect revenue in the fourth quarter to range between $51 and $54 million, which reflects $34 to $37 million of contribution from Space Systems and $17 million of contribution from Launch Services, which assumes 3 launches, or 1 remaining launch in the quarter, with one of those 3 launches being the attempted booster recovery R&D mission last week that was only partially filled, resulting in lower absolute and per launch contribution in the quarter. We expect fourth quarter GAAP gross margin to range between 5% and 7%, and non-GAAP gross margin to range between 16% and 18%. These forecasted GAAP and non-GAAP gross margins reflect the anticipated lower absorption of overhead expense in the Launch Services segment, as well as a higher mix of lower margin products within our Space Systems segment. We expect fourth quarter GAAP operating expenses to range between $39 and $41 million, and non-GAAP operating expenses to range between $28 and $30 million. This quarter-on-quarter increase is driven primarily by increased R&D staff costs and prototype expense related to continued growth in our investments in the Neutron launch vehicle and development and scaling of our Photon product family. We expect fourth quarter GAAP and non-GAAP net interest expense to be $1 million. And we expect fourth quarter adjusted EBITDA loss to range between $12 million and $16 million, and basic shares outstanding to be approximately 474 million shares. And with that, I'd like to open up the call to questions.
Thank you, Adam. During the Q&A portion of today's call, Rocket Lab will address a selection of questions from retail shareholders posted to our Q&A platform with Say Technologies. We'll begin by answering a selection of shareholder questions from amongst the top voted questions on the platform. We'll pass over any questions which are likely to have been answered already throughout today's presentation, and we may group together questions that touch on the same themes. But with that, the first question is from Daniel D., who asks, we are beginning to see major multinational corporations partner with space systems providers like Apple with Globalstar and General Dynamics with Iridium to provide more integrated services. Will Rocket Lab see a partnership similar to these in the future?
Okay, thanks, Muriel. Well, I mean, I guess the answer to this question is you can already see that we're a strong partner with Globalstar building their constellation, which is ultimately supporting some of those names. So the answer to the question is actually it's yes, we already are.
Thanks, Pete. Our next question is from Michael H., who asks, when will the company reach profitability?
Yeah, I'll take that one, Muriel. While most of the elements of our business have been ramping well, we're still in the early stages of our Neutron development and investment. So achieving and sustaining profitability can really only happen once we've gotten the majority of the R&D spending for Neutron in the rearview mirror. So yeah, I think that's the best way to look at it. It's really, we've got a couple things converging. We have an increased and kind of sustained investment in Neutron. And of course, that will come to a crescendo as we approach the launch. But we still need the rest of the business to grow and perform to overcome that investment in Neutron in the short term.
Thank you, Adam. The next question is from Kevin R., who wants to know, are there any more potential acquisitions Rocket Lab is considering in the near term?
Yeah, I can take that one as well, Muriel. So unfortunately, we can't speak to any specific acquisition opportunities, but we continue to see strategic inorganic growth opportunities in our markets. But there are no deals currently in advanced stage of discussion. We're very happy with the 4 strategic acquisitions we've done, and we do believe there are deals to be done both large and small that fit well within our end-to-end space solutions vision.
Our next question then is from Carter M., who asks, does Rocket Lab foresee any large military contracts in the near or distant future?
Yeah, I can take that one, Muriel. I mean, there's some pretty significant defense contracts we can't really discuss that we're actively working on. As you can imagine, a lot of these defense contracts are very long lead time processes. Generally, though, I can say we're seeing a really, an increased engagement from strategic DoD program opportunities that we think we can bring, a new level of stability and scale from our business to both launch and on the space system side.
Thanks, Peter. I'm going to summarize now some of the questions we've had for demand for launch services. So I'll put it forward as in this question here. What are the impacts on Electron's launch cadence? Is it customer readiness, level of demand, or any other factor that you might like to comment on?
Yeah, I can take a swing at this. I mean, I often compare a dedicated launch vehicle to like the difference between an Uber service and a bus. And the analogy is stronger than you think in the fact that on an Uber service, when you call it, that's when you call it and it arrives on your timescale. And that's kind of the same with the dedicated small launches. Is the value that we offer our customers, or one of the values is they can call us when we meet their timeframes. Now the challenge for us as always is if they're not ready on time, we're kind of the Uber left outside the restaurant waiting for someone to come outside. And this year I think we've done a really good job, certainly way better than previous years, of managing that by processing multiple customers at once. So if one customer has an issue during either an integration or processing, or even as they're getting their satellite prepared, we can kind of jump in front with another one. And we joke here, it's literally, we call it manifest whack-a-mole, where you continually fighting to keep the launch cadence. So the thing that affects our launch cadence the most is in fact customer readiness, less so demand. And when a customer slips, it's not that they go away; they just slip into a different quarter, or slip into in some cases a different year. So we've seen continued growth in demand, and which is pleasing to see. If we look at 23 and 24, we can see that that we have line of sight to our model closing. So that's all good. But I mean, yeah, customer readiness is the one thing that always is challenging to manage.
Thanks, Pete. Maybe another one for you. We've had several questions about Electron reusability from shareholders. The main points coming through have been what is the progress towards Electron recoverability, and to what extent will reusability drive down launch costs? And then finally, how does this process inform and help guide the design of Neutron?
Thanks, Muriel. I guess the question that most people will be asking is what happened on the last launch, and what we can say is that that during re-entry we need a telemetry lock with the vehicle so we can determine where it is in space, because it's not responsible to put a helicopter in a zone where there's potentially a re-entering rocket. So it's very normal for us to lose that telemetry link through the re-entry process because of the plasma and the heat and the barbecue roll that we put the stage in. And in this occasion, we didn't regain the lock in a time that was sufficient for us to put the helicopter into an area to be able to successfully catch it. And that was a safety call that we made, and we have very strict flight rules around that, and that was ultimately the call we made. But we still fished out of the ocean, and we continue to be very very, very confident that we're going to get there with this recoverability. And it's important to point out that our other friends down the road it took many attempts to successfully nail this. So that's probably the question on most people's mind, but more kind of directly to answer the questions that you had. Look, the majority of the cost of the rocket is in the first stage. If you can get that first stage back in a good condition and service it without having to rebuild it completely, then it is a very, very strong performance driver from a margins and cost perspective. So it's all goodness. And then with respect to Neutron, I mean, man, I wouldn't be wanting to develop a reusable rocket without having all of this knowledge and experience of re-entering launch vehicles and controlling them, and all of those things that comes along. Like it is technically a very, very challenging thing to do, but it's we're in really the best position possible given all the experience that we're learning from Electron, sorry. And it's directly applicable to Neutron, and making sure that Neutron out of the gate is very successful from a reusability standpoint.
Thanks, Pete. We've also had several questions about Rocket Lab's performance overall, which I'll summarize by asking how would you say Rocket Lab compares to other commercial space companies, particularly in small launch, but also across end-to-end space solutions?
Yeah, I'll take a first pass at this one, Muriel. I think we've distinguished ourselves in a few important ways. Clearly, launch heritage is the most obvious. As we noted earlier, we successfully launched more times this year so far than all other small orbital launch players, and we did this while establishing our leadership in responsive space, launching twice within 15 days. So I think those kind of accomplishments kind of speak for themselves and how we kind of view ourselves as being very separate and kind of unique with regards to the rest of the small launch group. Additionally, we think there was a window for paying customers to take a bet on a new small launch provider, but I feel like that window is really closed. It feels like we're now in a period where new launch providers are going to have to self-fund establishing a launcher with sufficient flight heritage for customers to be able to take risk. So I think that really goes to kind of future competition and even the people who have kind of already kind of made it through the first round, if you will. But there's a lot of work to do, and you have to kind of look at what the customer incentives are here, given kind of the state of development of the various players, including ourselves. And related with regard to the end-to-end space play, we were aggressive in acquiring, on-orbit heritage with our 4 acquisitions, and we're certainly leveraging that heritage into larger and larger end-to-end opportunities, very much like the MDA Globalstar program that we've talked a lot about. So again, I think there's very clear and obvious ways that we differentiate ourselves from the crowd, and we're very comfortable with the strategy and the execution against that so far.
Thank you, Adam. And with that, we'll be moving on now from shareholder questions. Thank you to everyone for your thoughtful engagement from our shareholders. We will open up the line now to questions from the analysts on the call. So over to you, operator.
Thank you. We will now begin the live Q&A. If you would like to ask a question, please press star followed by 1 on your telephone keypad. If for any reason you would like to remove that question, please press star followed by 2. Again, to ask a question, that's star 1. As a reminder, if you are using a speakerphone, please remember to pick up your handset before asking your question. We will pause here briefly as questions are registered. Our first question comes from the line of Matt Akers with Wells Fargo. Matt, your line is now open.
Yeah, hey, good afternoon, guys. Thanks for the question. I wonder if you could touch in a little bit more detail on the Q4 guidance for launch revenue. I think you mentioned why it was a little bit lower than what you might expect for 3 launches, but if you could go into some more detail there, and then how we should sort of think about ASB, does that still sort of ramp up as we get into next year? Thanks.
Yeah, sure, Matt. I'll take that question, and Pete can chime in if he views it differently. But so within the Q4 guide, I mean, obviously the biggest impact is having one of our customers, push their scheduled launch from Q4 into next year. It's kind of one of those things that don't get a lot of notice from the customer sometimes on these things. So that was kind of a late breaking change, more of a soft guide for Q4 on the launch service side of things. The other thing is we had our recoverability launch that we did last week, which it was really an R&D platform. It's we kind of look at it as almost like subsidized R&D. So we take a partially filled rocket so that otherwise we could fill if we weren't so schedule driven to make sure that we get a certain number of kind of attempted recoveries in place. So I think those were kind of really the primary movers. So that'll look like, when you look at the revenue contribution from launch in Q4, you might look like, well, the average selling price is going down to a much lower number, but it's really not, because that recovery ride share, again, was really more of an R&D mission. As we look forward, into 2023 and beyond, we actually see a pretty firm pricing environment for our product. We're not seeing any big discounts. I mean, occasionally we'll do some material discounts when customers are signing up for large bulk buys, as is the case with pretty much any other business. But right now we're feeling pretty good about where our pricing is, and again, over the last several years we've actually seen price increases. So yeah, I don't know if that answers your question, or Pete, if you have a different view.
No, yeah, that answers my question. Sorry, go ahead.
No, Matt, I was just violently agreeing with Adam.
Got it. Okay. No, thanks. That's helpful. And then, I guess if you could talk just, how are you thinking about next year? I don't know if you can give any help in terms of how we should think about growth at kind of the 2 different segments, kind of off of the Q4 run rate, if there's any early thoughts on that.
Yeah, I'll take a first pass at that as well. So, we're looking at, what we think will be actually a pretty impressive growth year on the Electron launch cadence. So, this year with the manifest we just kind of closed out, or, we have, again, that one more launch before we close out the year at 10 launches. We think there's significant growth. Right now we'd peg the estimated launches for next year at around 14, so about 40% growth year on year. And again, with fairly firm, I would say, pricing, we're still going to have a few R&D, efforts around booster recovery. So overall, kind of if you want to think about the pricing on average, kind of when that's all factored in, of somewhere around $7 to $7.5 million per launch. Again, some will be higher, some will be lower, particularly on the R&D booster recovery side of things. But so again, we're looking at good growth year on year for the launch business. And then when we look at the space systems business, we really have 5, if you said verticals, if you will, within space systems, and we see solid growth from 4 of the 5 areas. And if you think it's a reminder for those who aren't as familiar, so the areas would be, satellite design services, satellite manufacturing, satellite components, and then we have the on-orbit services management and / data services portion of the business. And really the only part within our mix right now that's looking to be a bit more challenged is on the solar side of the business, and that is primarily a function of the fact of revenue recognition around internal programs. So if we kind of step back and look at the strategic rationale for buying a business like SolAero, is particularly to make sure that we had complete control of as complete control as we can manage of our supply chain. So very strategic from that perspective. But as we take that merchant capacity at SolAero and we direct it towards internal programs like the MDA Globalstar program, for example, you end up having delays in revenue recognition. So as, for example, the products that are coming out of SolAero start to ship, ultimately with the completed satellites, we'll have that delayed revenue recognition at that time. So it's kind of a near-term hit to revenue as you kind of push that revenue recognition out. In our case, we'll start shipping those satellites in 2024. So it caused a bit of a pause to the business in 2023 for that particular product line. Again, until we get to revenue recognition as we ship the satellites in a meaningful way in 2024. But as I said, the rest of the business, if you look at the other 3 acquired businesses from Sinclair to SolAero and PSC, Sinclair, and ASI, we're seeing strong growth across those acquisitions. And our organic space systems business, as far as satellite design and manufacturing, that's growing as well. So we're really dealing with a bit of a challenge, just because such a large portion of our space systems revenue is coming from that SolAero piece, which again is being affected by the kind of revenue recognition or ASC 606 treatment.
Got it. That's helpful. Yeah, thanks very much.
Thank you. Our next question comes from the line of Scott Deuschle with Credit Suisse. Scott, your line is now open.
Hey, good afternoon. Thank you for taking my question. Pete, one of your peers in the launch industry they're building a oxygen-rich closed cycle engine as well, and I think it's fair to say it's been a bit of a challenge for them. And I recognize you guys have a great track record for execution, but can you maybe just talk a bit about what makes you guys comfortable with the development timeline you've laid out there for the team on Archimedes, and how you would give us some comfort about the risk of cost overruns or schedule slippage on that engine architecture? Thank you.
Yeah, hey Scott, it's a great question. So I guess the fundamental difference is generally the reason you go to an ox-rich or a closed cycle is for performance. So you're trying to extract the maximum amount of ISP out of a particular engine, and what that means is you end up with thrust or chamber pressures in many thousands of PSI, and that's always a good kind of way to determine like how stressed is an engine. Our rationale for going to the ox-rich cycle was not because we're trying to squeeze out huge amounts of ISP and really push chamber pressures. In fact, our chamber pressures are down at gas generator chamber pressures at sort of 1,500, 2,000 PSI, which is low. our rationale for going to the cycle was from a reusability standpoint. Ultimately, that cycle provides the best probability of reusability. So it's a long-winded way of saying we're not trying to push the cycle. Like generally, you go to that cycle because you need the performance. We're not going to that cycle because we need the performance, and we're not trying to extract the performance. So you basically have an engine that is very, very cold and not running up against the limits. So that gives us a lot of confidence in the development timeline because, for example, a pre-burner pressure in some of our peers' engines run at 11,000 psi or 8 to 11,000 psi, and we're just down at a few thousand psi. So what that ultimately means is the temperatures of the turbines, which are the things that cause you the grief, are very low, which means we don't need exotic materials, and ultimately the turbine tip stresses and strains are very low as well. So it's really taking an engine that normally someone chooses for performance and derating it right down to for our purposes, which is ultimate reliability. So we don't a rocket engine. There's always development challenges along the way, but when the team looks at what turbine speeds and pressures and temperatures that we need to achieve with the cycle, they're really, really boring, which is what we said we wanted to do, was make a very boring engine. So I wouldn't confuse like the cycle with the complexity. Yeah.
Okay, that makes a lot of sense. Thank you. And then Adam, you mentioned that some larger potential deals are maybe taking longer to close. Can you just talk a bit more about that? Is that the slowing of the sales cycle? Is that more on the commercial side, or is it more from government customers? Thank you.
Yeah, I would say it's a little bit of both, and I think it's also a function of the fact that we're not chasing kind of onesie twosie small deals anymore. We're chasing needle moving opportunities that just by definition are more complex. It's taking more kind of more of a holistic effort across the product lines in the company. So it's again all of this is kind of reinforcing the strategy of being an end-to-end player and having more to bring to the table and going after bigger and bigger game. And in this case, I think we've got a really good line of sight into that game that I think we're going to catch. But it's just taking a little bit longer. I don't think it's these things are taking I would say many quarters longer, but in some cases they're taking a little bit longer. And again, our confidence level is very high that we're going to close on some of these bigger material deals. So again, just complexity size is really, it's kind of a good thing in this case, but it does take a little bit longer than kind of one-off smaller kind of individual deals.
Got it. Thanks, guys, and congratulations on the progress.
Thanks.
Thank you. Our next question comes from the line of Erik Rasmussen with Stifel. Erik, your line is now open.
Yeah, thanks for taking the questions. I just wanted to real quick on the pricing. It seemed like there was a little bit of pressure this quarter because of the R&D, and but you're still thinking you're in the $7 to $7.5 million for next year. But how is pricing beyond, if we sort of exclude those R&D programs? Where is pricing today? Is it higher on average than what we're seeing currently and what we've seen throughout 2022?
No, still the kind of the average sticker price or kind of your basic mission is still running around $7.5 million. Again, some higher, some lower. We're not, when we're pricing out in time, we've got our pricing table that assumes a certain level of increases per year. Part of that is just to deal with the inflationary pressures that we're all dealing with. But again, we're not seeing a lot of dramatic pressure on the pricing side. I think customers realize the cost and the value of small dedicated launch, and they don't really compare us to things like rideshare, on an apples to apples basis, because it's really not a good apples to apples comparison. So again, pricing is holding up fine.
Okay, and then on margins, coming down next quarter, How do you just trying to get a sense of where the pressure's coming from. Is it still Celero? Is it something else? And then how should we be thinking about margins for next year, or just directionally? Because we've seeing a step down here. We've seen some pressure throughout the year. Should we still be looking at Celero as potentially having 30% margins at some point, and are we still on track for that?
Yeah. So I'll take those in a couple different pieces. So on the overall margin directionality. So on the launch side, whenever you have less revenue contribution from launch, then you have less production overhead absorption, right? So the fact that we have 3 launches, but one of them is heavily subsidized R&D, it just doesn't give you as much air cover for that. So I think I think what we saw in our Q3 results is the positive trend of increasing gross margin when we have 3 full price launches. So 1 launch per month, kind of on the undiscounted normal launches, that gets us on our path with all the cost reduction activities that we have going on for Electron margin improvement. Really, again, give us confidence that we're pointed in the right direction. On the launch side, I think that again, it's all about having at least 1 launch per month in the quarter. When you've got anything less than that or a subsidized kind of launch in the quarter, that kind of starts to eat into that in a meaningful way. And again, we're just kind of getting underway now for some meaningful margin improvement projects on Electron specifically, as we've now gotten that product stabilized and we're looking to really turn the crank on profitability. When you think about the space systems margins side of things, it's kind of you've got a little bit of a yin and a yang here, right? You have I mentioned earlier when Matt asked the question about growth in 2022 and Celero being impacted by revenue recognition for internal programs that they would not have been impacted by if they were just selling out into the broad merchant market. That's a bit of a blessing and curse because we'll have less kind of relative contribution from Celero in at least for the majority of 2023 as they continue to ship into these internal programs and we don't get to recognize the revenue. So that means that the rest of Space Systems will contribute more, relatively speaking, and that should be helpful to the overall margins for Space Systems. I think when you look at Celero's gross margins in isolation, we've done a lot of work with that team. We think there's a great opportunity to pull those gross margins up, very much in line with what we'd originally been talking about, getting to 30 points. So I think there's just some distortions that are happening in the near to intermediate term because of the internal programs. So you won't really necessarily see all of that margin improvement come through in a more visible way. But again, overall for Space Systems, because of that mix that we talked about and the fact that the rest of our Space Systems products have very high gross margins, we think overall that should be a positive uplift to Space Systems margins as we progress forward.
Great, thank you.
Thank you. Our next question comes from the line of Suji Desilva with Roth Capital. Suji, your line is now open.
Hi, Peter. Hi, Adam. On the launch count guidance for 23 to 14, what's the realistic expectation for how many of those might be out of Virginia? Is it kind of 1 a quarter early on? I know you said one's going to come on early in 23, and would that progress towards sort of 1 a month over time?
Pete, do you want to take that?
Yeah, that's a good question. I'd have to actually pull up the manifest and see where they've kind of spaced throughout the year. But getting a couple away early in the year is helpful. And then I would kind of imagine them fairly sporadically through the year. Because we haven't had the range operational for a while, we've been kind of cautious in what we book for that site. So I would say that you'll sort of see them sporadically through the year and then perhaps start to increase nearer the end of the year. Just from the natural life cycle of a launch contract.
Yeah, Suji, I mean, right now, when we look at our manifest, we would estimate somewhere between 4 and 6 launches of the 14 would come out of LC2 in Wallops.
Great. And then, Adam, without going through a full accounting discourse on revenue recognition for these projects. Kind of maybe what's going in and what's kind of coming out, kind of recognition for the Globalstar MDA agreement. I know you're selling certain products in. Is it recognized when satellites are fully manufactured? Just give us kind of a thumbnail of that so we can understand.
Yeah, we'd have to have a lot more time than is allocated on this call, and we'd certainly set some time aside to talk about it offline because the accounting treatment on ASC 606 gets very complicated. But the way you can think about it is there is a nominal amount of revenue that gets realized as you're building up the program, but it's kind of more kind of materials and inventory driven changes. You realize the bulk of the revenue from these programs, whether it's the MDA Globalstar one, that's obviously a very large one, but other contracts that we have like Escapade is when you actually ship the hardware. So when we actually ship the satellite, that's when we get to recognize the majority of the revenue. So, I mean, a lot of what that really says is that, as we've disclosed all of these really exciting satellite projects that we're working on that will be making meaningful progress in 2023 and ultimately ship in volume in 2024, that really kind of sets the stage well for 2024 when we'll have a lot of what's called spring-loaded revenue as a result of not being able to recognize that kind of ratably over time. So, if you kind of think about I can't give you a percentage of the total contract value that gets recognized in kind of 23 versus 24, but I think roughly speaking, probably 80% of the revenue for example, that Globalstar MDA contract, won't be recognized until 2024. So probably 20% in 2023, and the remainder of it in 2024.
Very helpful, Adam. Thank you.
Sure.
Thank you. Our next question comes from the line of Kristine Liwag with Morgan Stanley. Kristine, your line is now open.
Thanks. Hey, Peter. Hey, Adam. You're now at a launch cadence of about one per month for Electron, and you've already done 30 launches so far. When do you anticipate to record positive gross margin and launch? Should this be around unit 35, unit 40? Some sort of unit guidance would be helpful. And then also, Adam, you mentioned that pricing's getting better. We saw SpaceX raise prices this year. Is that an opportunity for you to potentially get to that positive gross margin sooner?
I'll take the first part of that question. I'll let Pete talk to the longer-term pricing leverage and dynamics. But so obviously we're at a positive gross margin now on a non-GAAP basis. But you're right, it's negative on a on a GAAP basis. Again, a lot of good things happen when we're launching, more than once per month. So GAAP profitability. That's probably, when we get maybe our launch cadence up to, I'd call it 5, probably, I'd say a solid 4 fully priced launches per quarter is probably where we kind of move into that positive GAAP gross margin level. And the margins that we've been targeting all along have really been, when we say 50% gross margin for our launch business, it's really a non-GAAP figure. So again, I think that the GAAP numbers get confused by a lot of non-cash items around amortization and so forth, depreciation charges. So it does take a little bit more of a step up, and a regular cadence of, let's call it 4 fully priced launches per quarter would get us into that solid GAAP gross margin profitability. And Pete, I don't know if you want to speak to the pricing with regards to SpaceX increasing their pricing recently.
Yeah. Look, I think everybody feels the pressures of supply chain and the increase in cost. And kind of to Adam's point, Electron's pricing has done nothing but go up since we first started flying. If you look forward at future pricing, it's certainly more reflective of that environment. So. Yeah, like I think Adam said, any other questions, we don't see the pricing increasing anytime soon.
Thanks. And maybe Peter, following up on retrieval, I mean, after last week's helicopter retrieval attempt, you explained that the chances for success are much smaller than those for failure because of many complex factors must perfectly align. So I just want to unpack this a little bit. How are you thinking about the success rate of each retrieval attempt then going forward? And then also, has last week's attempt changed how you're thinking at all on the helicopter approach?
It's a good question. Look, I mean, I think it's important not to throw the baby out with the bathwater here. I mean, I don't know how many, 7 or 8 attempts I think it took SpaceX. I could be wrong on that number, but this is our second proper go at it, and we fundamentally caught it on the first attempt. So I think it is an R&D program. The stuff we're going to learn, yeah, it's complex, but that, like, if it was easy, then everybody would be reusing rockets, right? And so you have to endure the pain of getting through the R&D portion to operationalize it. What I would say, I think, what started off as something that we weren't even sure we can do is something now that around the business is just absolutely standard. There's reusable vehicles running down the production line, and to be honest with you, everybody kind of falsely expected that we would just catch this one, and there was things pulled up for all ready to receive it and refurbish it. But the reality is, we're still learning stuff, but it's still, this is catch number 2, so we've got a long way to go yet before we would abandon it for whatever reason. So no, I'm happy with where we're at. It would have been nice to catch it, but we learned a lot.
Yeah, I mean, I'd love to see you guys catch that too. And maybe if I could do one more, from the recovered Electron engines from the ocean that you've been recovering, how's been the wear and tear versus what you expected? And then considering the cost of refurbishing those wet engines, how does that track versus expected cost savings when you're able to successfully recover a dry one?
Yeah, that's a great question. Actually, way better than we thought. It always amazes me when we pull stuff out of the ocean, a flight computer, for example, and it literally looks like it's got barnacles on it. It's all fizzy and horrible, and you unplug it in and it just fires up. Now, not that we'd ever fly a flight computer that's got a barnacle on the side of it, but my point being is that the system is designed to be incredibly reliable from day one. So by nature, it means that the systems seem to be incredibly robust to very off-nominal environments and conditions. And the engine that was pulled and reserviced, there was nothing in that engine that anybody was kind of surprised or frightened at. It was in remarkably good shape. I think part of it is getting over the fact that it actually got dunked in the sea rather than anything actually technically wrong with it. So that's what gives us confidence in the pursuit of this for Electron, is that is the condition and the serviceability that we've been finding stuff has been really good, and that also feeds directly into the Neutron team as well. So when we bring Neutron to market, there's not going to be a massive learning curve there to achieve what we need to achieve. Literally, and almost purposefully, the recovery team sits in the same building as the Neutron team. So, they're all sharing each other's experiences, and we see the design of Neutron, being tweaked real time with everything we learned from Electron.
Great. Thanks, Peter.
Okay.
Thank you. Our next question comes from Austin Moeller with Canaccord. Austin, your line is now open.
Hi, good afternoon, Peter and Adam.
Hey, Austin.
Hey, Austin.
So just my first question here, if we think about the launch recovery, is there anything we can do on the vehicle itself in terms of an antenna to improve the connection in the event of just given the telemetry losses? I mean, I know like SpaceX has built some redundancy around that, and I was just wondering what your thoughts would be, just given you need the helicopter, just given the mass requirements.
Yeah, it's quite, every re-entry is a little bit different. So, on a SpaceX re-entry, they obviously do an entry burn, which slows their velocity through the wall, which is the most intensive part of the re-entry profile. For us, we don't do any of that. We bring it in straight through. So we have quite the build-up of thermal energy at the base that we manage, and plasma around the launch vehicle. So, and you find, from an orbital re-entry standpoint, there's always a communications blackout. Once your vehicle is enveloped in plasma, there's very little any antenna can do to penetrate, that kind of RF. So we do have a slightly different entry environment, well, quite a significantly different entry environment to others in that front. But obviously we're not going to we're going to take lessons from this and try and improve improve that. I mean, we had successfully regained length pretty rapidly in previous launches. This one, unfortunately, we didn't. So we'll obviously get to the bottom of why that didn't occur. But I should just point out it's a non-trivial environment and challenging environment. It's quite different to others that we have to deal with on a re-entry.
Right. So I guess from that perspective, it's just to be expected that, kind of like during the Apollo program, they anticipated there would be a communications blackout on the ballistic return.
Correct, and it's not the same energy, of course, for re-entry or energy over time. Probably similar energies, but just not over the time. So yeah, like I say, it's fully expected during that high plasma environment.
Okay, and then this might be a question for Adam, but where are we at in terms of the existing contracts within SolAero and those progressively being replaced by newer contracts that are working towards higher margins, and where are we at in your progress on the integration of that company?
Yeah, so I would say that we continue to be on track to kind of that margin target that we'd set of 30% within 2 years of the deal close. So we've got some time. We are making progress towards it on a quarterly basis. I would say as far as churning through the old contracts, as we kind of obviously burn through backlog, we're getting there. But I would say too that there was a non-trivial amount of business that was still to be worked through, and some of it came at relatively low gross margin, albeit reasonable kind of standard margin. And you kind of think about the kind of a more of a classic semiconductor manufacturing environment. Covering your fixed costs are obviously important to a certain extent, and you have to look at that in the context of how you choose to take certain business, because you have a lot of kind of just recurring kind of fixed costs that flow through the business. So I think that, again, nothing is deterring us from the 30%. I think that, again, we're making progress towards it. I think it's not just something, too, where you have to burn through the old contracts, because the old contracts can deliver higher gross margin if you can affect changes in your production overheads. So we're looking at everything that we can do to not only kind of bring in new contracts at higher gross margins, but also affect what ultimately we can deliver on the existing backlog as we reduce our overhead costs. And again, we're attacking this from every angle, and we're making progress. So again, I'm confident with the numbers that we put out there. I don't think there's any reason to shy away from those.
Okay, fantastic. Well, thanks for filling me in.
Sure.
Thank you. Our next question comes from the line of Ron Epstein with Bank of America. Ron, your line is now open.
Hey, everyone. You actually have Andre Madrid on for Ron today. Quick question. Looking at the selection of the Stennis Space Center, how do you see that having an impact on CapEx spend? And then with that being said, what are you guys kind of projecting in terms of CapEx moving forward? What kind of rate?
I can take the first swing at that, and then you
go ahead.
talk about the.
Go ahead, Pete.
Sorry. So on kind of the reduction of CapEx spend that Stennis enables us is pretty significant, right? I mean, if you look at the infrastructure that's there, it's massive. So it really, as we kind of mentioned, helps us accelerate the kind of program from being, building just an absolute bare bones, engine test stand, through to moving into something that is really quite significant from day one, which helps accelerate us through the early, but also the mid and longer points of the program. So really significant piece of infrastructure that obviously we didn't have to CapEx, so from that perspective, a huge win. But I'll throw it over to you, Adam. Talk about overall CapEx and rate.
Yeah, I mean, overall CapEx has kind of been staying in a certain range. Let's call it I think this quarter was a little under 10 million in the quarter. I think you're going to see that CapEx continue to step up as we continue to put infrastructure in place for Neutron. I think on our space systems business, we're pretty much there as far as infrastructure required to execute on our plan. There'll be a little bit of additions here and there, but on Neutron, we're still very much in the early phases of getting that infrastructure put in place. So I think you'll start to see that roughly kind of $10 million per quarter CapEx number kind of sequentially increase, and probably ends up I'd say peaking at in the kind of 25-ish kind of million per quarter rate. It'll take a few quarters to get there, and then it'll start to tail off. But when we talked about the Neutron program, initially we said it was a $200 to $250 million program, split between if you think about the prototyping and personnel costs as well as CapEx. CapEx we anticipated to be kind of in the $80-ish million for CapEx for the program, with the remainder falling into personnel and prototyping. The mix on a program like this is always going to be hard to pin down exactly, but I would say right now we're probably trending a little bit more towards higher CapEx and maybe a little bit less on prototyping and personnel side of things. So again, I think that in order for us to hit our 2024 first flight of Neutron, we'll have to have a pretty significant portion of that infrastructure in place as we exit 2023. So I'd expect or I'd say exit 2023, but certainly before the middle of 2024, you'll see kind of a gradual increase in that CapEx from our roughly $10 million per quarter rate. At some point we'll peak, kind of in that kind of mid-20s, and then we'll be pretty much kind of in place. So I don't know if that kind of helps you dial in your model at all, but that's kind of roughly what we're looking at today.
Yeah, no, definitely. That's very helpful. And do you think in any way the selection of Stennis could actually maybe accelerate so that there could see a launch earlier than expected, or are you keeping your timeline kind of at the same as it was before?
Yeah, it's definitely a Pete question.
Man, yeah, I mean, it's already an aggressive timeline. So no, I'm not prepared to knock time off that at this stage. Certainly, I think it's an accelerator in the short, but more impactfully, it's an accelerator in the medium to long term. But we'll hold to our dates at this point.
All right, that's helpful. That's all I have. Thanks, guys.
Thanks, Andre.
Thank you. Our next question comes from the line of Cai von Rumohr with Cowen. Kai, your line is now open.
Yes, thanks so much. I know it's been a long call. I'll keep it to one. So you mentioned, more launch recovery attempts in 2024. How many more, and why the lower price? I mean, I can understand why the costs would be higher, but why the lower price? And maybe if you can give us kind of a range of where the price would be for one of those R&D launches. Thanks.
Yeah, I'll take a first pass at that, as Pete, as far as the the cost and the pricing side of things. So Kai, you can think of this as being it's much more important for us to get the catch attempt in hand. So what we do is we set the R&D team, say, hey, you're going to be doing a recovery at this point in time, so drive all your plans around that. And then we basically try to subsidize the cost of that recovery mission with whatever payloads will fit into that defined time scale, right? So it's much more important for us to get the mission off, even if we sell the rocket half full, which is kind of a decent proxy kind of for what we've been doing for these ride shares. So if you think about a $7.5 million mission, we've been selling roughly half the capacity, and the reason why we can't or haven't done more is because we've chosen to stick to a recovery schedule and maximize the revenue on that recovery flight. So you're right. There's nothing that would prevent us from basically filling up that and getting full revenue for that, other than the fact it would result in a delay in our R&D process for establishing the recoverability. So it's just a trade that we make. We take less revenue cover to get more frequent recovery launches in place.
And then how many more of these R&D launches are you going to take? I mean, just until you get it right, or how should we think about that?
Yeah, Pete.
Yeah, I mean, sorry, I was mashing my mute button. So on these R&D launches, like it kind of Adam pointed out, we're unfairly optimizing them for our schedule, and I think we had to with some degree of certainty be able to provide dates to the team to be able to meet. Now the development of the recovery system is slowed right down. I mean, obviously some tweaks we need to make, but it's not like where we were a year ago where we were, fundamentally making block changes to the vehicle. Now there's just a standard vehicle running down the production line, recovery vehicle. So it's kind of a long-winded way, Kai, of saying that we don't anticipate really to be doing too many more of these kind of subsidized R&D missions at this point. We're pretty much ready to start moving into this as just a standard thing.
Excellent. Thank you very much.
Thank you. There are currently no further questions in queue. So again, as a reminder to submit for a question, that's *1 on your telephone keypad. There are currently no further questions in queue. So I will pass the conference back over to Peter for any additional or closing remarks.
Okay, thank you everybody for your interest in Rocket Lab and those who have participated in today's call. Adam and I will be speaking at these upcoming conferences and look forward to the opportunity to share more exciting news and updates at the Stifel Midwest Growth Conference on November the 10th and the Deutsche Bank Global Space Summit on the same day, and then Roth's 11th Annual Technology Event on November the 16th. So thanks again, and we look forward to speaking with you all again soon about the exciting progress we've made in the business.
Thank you. This concludes today's Rocket Lab third quarter 2022 financial results conference call. Thank you for your participation. You may now disconnect your line.